There's something deeply unsettling about looking up at the night sky and realizing somewhere out there, the universe is playing a trick on us. Picture this: galaxies, swirling islands of stars, each containing billions of suns, all drifting through the endless dark. Now, imagine finding out they're not scattered randomly as they should be. Instead, they're eerily aligned, stretching across the cosmos in a pattern so precise, so deliberate, it defies every law of physics we know. This isn't science fiction, it's real. Scientists call it the axis of evil, and it's one of the most baffling cosmic anomalies ever discovered. If the universe is supposed to be a chaotic, unpredictable place, why does it seem to be following a hidden blueprint? This isn't just a curiosity, it's a crisis for physics. The axis of evil isn't just a quirky name, it's a direct challenge to our most fundamental assumptions about how the cosmos works. From the Big Bang to the way light travels across space, everything we thought we knew might be wrong. And here's the thing, this isn't some fringe theory. These anomalies show up in the most precise measurements we have, data from satellites like Planck and WMAP, which map the afterglow of the Big Bang itself. The universe, it seems, has a preferred direction, a cosmic spine running through space, and no one can explain why. But that's exactly what makes this so thrilling. The axis of evil isn't just a problem, it's a doorway. If we can crack this mystery, we might uncover truths about reality itself, hidden dimensions, flaws in Einstein's theories, or even evidence of something beyond our universe. This is where the edge of human knowledge meets the unknown, and that's where things get truly exciting. So, if you've ever wondered whether there's more to the cosmos than meets the eye, buckle up. Because today, we're diving into the anomalies that break physics, the enigmas that keep scientists awake at night, and the discoveries that could rewrite the story of everything. The universe is stranger than we imagined, and we're just getting started. The axis of evil sounds like something ripped straight from a sci-fi thriller, but it's a real cosmic puzzle that's shaking the foundations of modern physics. At its core, it's a bizarre alignment in the universe, one that shouldn't exist. According to everything we know, the cosmos should be uniform in all directions, a fundamental idea called the cosmological principle. Picture tossing a handful of glitter into the air. You'd expect it to scatter randomly, right? That's how the universe is supposed to work. But instead, when scientists mapped the cosmic microwave background, the faint afterglow of the Big Bang, they found something shocking. The hot and cold spots in this radiation, which should be distributed evenly, actually line up along a specific axis, almost as if the universe has a hidden equator. Even stranger, the same alignment shows up in the way galaxies rotate, as if some unseen force is tugging them into order. This isn't just a small anomaly. It's a direct violation of one of cosmology's most sacred rules, the idea that the universe has no preferred direction, no special place. If the cosmos were a classroom, the cosmological principle says every seat should be equally good. But the axis of evil suggests there's a front row and it's pointing somewhere. The implications are staggering. If true, it means our understanding of gravity, the Big Bang, even the shape of space-time might be missing a critical piece. Some researchers have proposed wild explanations. Could it be evidence of a parallel universe bumping against ours, or a flaw in Einstein's theory of relativity? Others argue it's just a statistical fluke, a cosmic mirage we're misreading. But here's the kicker, the data keeps coming in and the anomaly refuses to vanish. What makes the axis of evil so unsettling is how quietly it upends our assumptions. For centuries, we've built our theories on the idea that the universe is fundamentally fair, that no direction is special. But now, we're staring at evidence that maybe, just maybe, we're not just floating in a random patch of space. We might be part of something far more structured, more deliberate than we ever imagined. And that raises a chilling question. If the universe has a hidden axis, what else don't we know? the year 2005 should have been a moment of triumph for cosmology. NASA's Wilkinson Microwave Anisotropy Probe, known as WMAP, had spent years painstakingly mapping the cosmic microwave background, the oldest light in the universe, a fossil from the Big Bang itself. Scientists expected confirmation of their most basic assumption, that no matter where you looked, the universe would appear roughly the same in all directions. But as the data came in, something impossible emerged. Tiny temperature variations in that ancient light, fluctuations so small they represent differences of just millionths of a degree, weren't randomly scattered like static on an old television screen. Instead, they lined up along a mysterious axis, as if someone had drawn an invisible line through the cosmos and whispered, "This way is special." At first, researchers thought it must be a mistake. Maybe an error in calibration or some lingering effect from our own solar system's motion. But the more they checked, the more the signal held. The hot and cold spots weren't just aligned. They formed a pattern that spanned the entire observable universe, like a cosmic fingerprint pointing toward the constellations Leo and Hydra. Even stranger, when astronomers later analyzed data from the Planck satellite, an even more precise instrument launched in 2009, the same unsettling alignment appeared again. Two separate missions, years apart, both seeing the universe break its own rules. What makes this discovery so disruptive is how fundamentally it contradicts our picture of cosmic evolution. The standard model of cosmology relies on the idea that the early universe was perfectly smooth, with random quantum fluctuations that eventually grew into galaxies. Those fluctuations should have left a signature in the cosmic microwave background, but one that looks like a snowstorm, not a carefully drawn arrow. Yet here we are, staring at evidence that the universe might have handed us a compass instead of a snow globe. Some researchers have compared it to walking into a room where confetti was thrown in the air, only to find every piece mysteriously aligned in neat rows. The most unsettling possibility, this alignment might not be an illusion at all. If the axis of evil is real, it implies forces or structures operating on scales we can't yet comprehend, perhaps relics from before the Big Bang, or evidence that our universe is just one thread in a far larger cosmic tapestry. Imagine spinning a globe and realizing that all the mountain ranges inexplicably line up with some unseen meridian. That's the scale of the mystery we're facing. And as for what's causing it, the honest answer is we don't know. But that uncertainty is where the real adventure begins, because every great revolution in science starts exactly like this, with an anomaly that refuses to go away, a whisper in the data that says, "Look closer." From Galileo's telescope revealing moons around Jupiter to the discovery that galaxies were moving away from us, history shows us that when the universe throws us a curveball, it's usually hiding a truth far stranger than we'd imagined. The axis of evil might just be the next chapter in that story, one that could rewrite everything we thought we knew about space, time, and the very nature of reality itself. The cosmological principle isn't just some obscure scientific jargon, it's the bedrock of modern astronomy. Think of it as the universe's rulebook, the assumption that no matter where you stand in the cosmos, the view should be roughly the same in every direction. No special vantage points, no cosmic VIP sections. It's why we can study distant galaxies and trust that the laws of physics work the same there as they do here. But the axis of evil doesn't just bend this rule, it shatters it. Imagine walking into a perfectly round room where every wall is identical, only to discover one of them is subtly glowing. That's what scientists faced when they realized the cosmic microwave background wasn't the random mess of hot and cold spots they expected. Instead, it looked like someone had drawn an arrow through the universe, pointing in a specific direction. This wasn't just a minor hiccup, it was like finding out gravity works differently depending on which way you're facing. Suddenly, the universe wasn't playing fair anymore. The debate among physicists has been fierce. Some argue this alignment is a fluke, a statistical oddity that will vanish with better data. Others, like renowned cosmologist Joe Megiddo, have called it a crisis for cosmology. And they're not exaggerating. If the axis of evil is real, it means our entire understanding of cosmic structure, from galaxy formation to the fate of the universe, might need a rewrite. But here's where it gets even weirder. This isn't just about the cosmic microwave background. Observations of galaxy rotations show a similar preference for alignment along the same axis, as if some invisible hand is gently nudging them into formation. It's not just one anomaly, it's a pattern, a cosmic conspiracy pointing towards something we don't yet understand. Could this be evidence of a pre-Big Bang structure? A sign that our universe is just one bubble in a vast multiverse? Or is it proof we've been missing a fundamental force all along? The stakes couldn't be higher. If the cosmological principle falls, so does much of what we thought we knew about space and time. Einstein's relativity, the Big Bang model, even our theories about dark matter and dark energy, all of them rely on the assumption that the universe is uniform. That's why the axis of evil isn't just a scientific curiosity. It's a ticking time bomb under the foundation of modern physics, and the more we study it, the louder the ticking gets. Buried within the cosmic microwave background like a ghostly fingerprint lies one of the most perplexing discoveries of modern cosmology, the cold spot. This vast, eerie region of space, stretching nearly 2 billion light-years across, registers significantly colder than its surroundings, defying all expectations of what the afterglow of the Big Bang should look like. If the universe's early light is a mostly uniform sea of microwaves, this spot is like an unexplained shadow, a cosmic chill that shouldn't exist. At first glance, you might think it's just an empty void, a place where matter simply didn't clump together like the rest of the cosmos. But here's the catch: even the emptiest regions of space don't explain the cold spot's extreme temperature drop. Simulations show that a void large enough to cause this effect would be so absurdly vast, it would challenge our understanding of how structure forms in the universe. And that's where things get even stranger. Some theorists have proposed an idea straight out of science fiction. What if this isn't just an empty patch of space? What if the cold spot is a bruise, a remnant of a collision with another universe? The multiverse theory suggests our cosmos might be one bubble in an infinite froth of universes, each with its own physical laws. If another bubble brushed against ours in the early moments of creation, the energy released could have left behind this telltale cold region like a fingerprint pressed into the fabric of reality. It's a radical idea, but the cold spot's peculiar properties make it hard to dismiss. The Planck satellite's detailed maps show it's not just cold, it's surrounded by a strange ring of warmer radiation, a pattern that fits the shockwave-like aftermath of a cosmic impact. Yet not everyone is convinced. Skeptics argue it could still be a statistical fluke, a trick of perspective, or some unknown quirk in how we interpret the data. But the cold spot refuses to vanish under scrutiny. Even more intriguing, it lines up roughly with the same mysterious axis that defines the axis of evil, as if the universe is pointing us toward something. Whether it's evidence of a parallel reality or a flaw in our theories, one thing is certain: this cosmic anomaly is a glaring reminder that the universe still holds secrets we've barely begun to uncover. Because if there's one lesson science keeps teaching us, it's that the most unsettling discoveries often lead to the greatest breakthroughs. The cold spot might just be the next puzzle piece in a much larger picture, one where the universe isn't just stranger than we imagine, but stranger than we can imagine. And that's what makes the hunt for answers so electrifying. Every unexplained shadow, every cosmic anomaly is a clue waiting to be deciphered, and who knows? The next great revolution in physics might start with a single patch of cold in an otherwise uniform sky. If the axis of evil and the cold spot weren't strange enough, wait until you hear about dark flow, the discovery that entire clusters of galaxies are racing toward something we can't see. Picture this, you're watching hundreds of boats on a lake, all drifting randomly with the currents. But then you notice something odd. They're all gradually being pulled in the same direction, as if some invisible undertow is dragging them toward a hidden drain. That's essentially what astronomers have observed in the cosmos, except instead of boats, it's massive galaxy clusters hurtling toward a single point beyond the edge of our observable universe. This isn't just a subtle motion. These galaxies are moving at speeds exceeding 2 million miles per hour, far faster than our models of gravity and cosmic expansion can explain. Even stranger, the direction of this flow lines up suspiciously close to the axis of evil and the cold spot, as if the universe is pointing us toward some unseen attractor. Scientists call it dark flow because, much like dark matter and dark energy, it hints at forces we don't yet understand, forces so vast they're tugging on entire superclusters of galaxies like puppets on strings. The leading theory is as mind-bending as it sounds. Whatever's pulling these galaxies might lie outside our universe. Imagine standing in a room with no windows, feeling a breeze you can't explain. That's the position cosmologists are in. Some speculate that dark flow could be evidence of a neighboring universe, one with different physical laws, whose gravity is leaking into ours. Others suggest it might trace back to the chaotic conditions of the early cosmos, a relic of uneven forces during the Big Bang itself. But here's the catch: our current laws of physics say nothing beyond the observable universe should affect us. The cosmic speed limit set by relativity means no signal, no force, no influence should reach us from outside our cosmic horizon, yet the data refuses to cooperate. Skeptics argue it could be a measurement error or a quirk in how we interpret galaxy movements, but the more we look, the more the evidence stacks up. NASA Chandra X-ray Observatory and the Planck satellite have both independently detected this mysterious motion, ruling out simple explanations. If dark flow is real, it implies our universe isn't just lopsided, it's being pulled. That realization sends shivers down the spines of physicists because it suggests there's something out there bigger than our entire cosmos, something we can't see, can't measure, and can't yet explain. And that's what makes dark flow so thrilling. It's not just another cosmic anomaly. It's a potential window into the unseeable, a clue that our universe might be part of something far grander. Whether it's another universe, a flaw in Einstein's theories, or something entirely new, one thing is clear: the cosmos is trying to tell us a story. The only question is whether we're ready to listen. Quantum mechanics has always thrived in the realm of the bizarre particles that exist in two places at once, entangled twins communicating instantaneously across light years, vacuums bubbling with phantom particles. But even this famously strange branch of physics might not be weird enough to explain cosmic anomalies like the axis of evil or dark flow, the unsettling truth. Our most successful theory of the small-scale universe crashes headlong into the mysteries of the cosmos at its grandest scales. Take quantum entanglement, for example. When two particles become linked, changing one instantly affects the other, no matter how far apart they are. Einstein famously called it spooky action at a distance, yet experiments prove it's real. Could some quantum link woven into the fabric of space-time explain why galaxies billions of light-years apart seem to move in sync? A handful of physicists think so, proposing that entanglement might operate on cosmic scales, stitching the universe together in ways we can't yet measure. But here's the problem: quantum effects typically fizzle out at larger scales, vanishing into the statistical averages of classical physics. For quantum weirdness to influence entire galaxy clusters, we'd need mechanisms far beyond anything in our textbooks. Then there's string theory's promise of hidden dimensions, tiny, curled-up folds in space-time too small to detect directly. Some theorists suggest these extra dimensions might warp gravity subtly over vast distances, creating the illusion of dark flow or the axis of evil's eerie alignment. Imagine blowing across the surface of a pond and watching ripples move in unison. What if extra dimensions are blowing on our universe from the outside? It's a poetic idea, but one with shaky experimental footing. After decades of searching, we've found zero direct evidence for these hidden dimensions, leaving them in the realm of tantalizing speculation. But the most radical possibility: these anomalies aren't just gaps in our knowledge, they're proof we need entirely new physics. Modified gravity theories like MUND rewrite Einstein's equations to explain galaxy rotations without dark matter. Could similar tweaks account for cosmic alignments? Others propose the Big Bounce theory, where the Big Bang wasn't a beginning but a rebound from a previous universe's collapse. In that scenario, the axis of evil might be a scar, a remnant of pre-Big Bang structure imprinted on our cosmos like a fossil in stone. The stakes couldn't be higher. If quantum mechanics or hidden dimensions can't explain these anomalies, we might be standing at the edge of a paradigm shift as profound as relativity or quantum theory itself. History shows us that when the universe throws us puzzles this persistent, the answers usually rewrite the rules. Whether it's a hidden quantum cosmos, unseen dimensions, or laws we haven't dreamed up yet, one thing's certain: the universe is daring us to think bigger. And that's where the real adventure begins. Dark energy is the universe's most enigmatic architect, an invisible force relentlessly stretching space itself apart, driving galaxies away from each other at an ever-increasing speed. We don't know what it is, only that it makes up roughly 70% of the cosmos and behaves unlike anything else in physics. But could this mysterious energy also be the hidden hand behind the axis of evil? Some scientists think dark energy's influence might not be as uniform as we once believed, and that its irregularities could be warping space-time in ways that create these eerie cosmic alignments. Picture space as a vast rubber sheet. In Einstein's relativity, massive objects like stars and galaxies dent this sheet, creating the curvature we call gravity. Dark energy, on the other hand, acts like someone pulling the edges of the sheet taut, accelerating its expansion. But what if that pull isn't perfectly even? Imagine tugging on a wrinkled blanket. Some areas smooth out, while others bunch up unexpectedly. If dark energy has subtle variations, ripples in its strength across the universe, it could twist space-time just enough to nudge galaxies into strange alignments or leave imprints like the axis of evil. This idea turns conventional wisdom on its head. For years, dark energy was assumed to be perfectly uniform, a smooth, featureless backdrop to cosmic evolution. But the axis of evil suggests the universe might have a directional preference, a cosmic grain like wood that's easier to sand in one direction than another. If dark energy isn't uniform, if it's stronger in some regions or aligned along certain axes, it could explain why the cosmos seems to have a special direction. Some theories even propose that dark energy interacts with dark matter in ways we don't yet grasp, creating large-scale tensions in space-time that manifest as these anomalies. The challenge is testing such a radical idea. Dark energy's effects are subtle, visible only across billions of light-years, but upcoming telescopes like the Vera Rubin Observatory and the Euclid Space Mission are designed to map the universe's expansion in unprecedented detail. If they find patterns in how dark energy behaves, clumps, waves, or directional biases, it could finally connect the dots between this mysterious force and the axis of evil's unsettling order. Of course, not everyone's convinced. Critics argue that dark energy's uniformity is baked into our most successful cosmological models, and tweaking it risks unraveling more than it explains. But history has shown us time and again that the universe delights in defying our expectations. If dark energy isn't the pristine constant we thought, but a dynamic, textured force with its own hidden structure, it wouldn't just solve the mystery of the axis of evil, it would rewrite our understanding of reality itself. The cosmos is under no obligation to make sense to us, and that's exactly what makes the hunt for answers so exhilarating. What if the axis of evil isn't just a cosmic anomaly, but a scar, a fingerprint left behind by another universe brushing against ours? Multiverse theories suggest exactly that. Imagine dipping your finger into a pool of water. The ripples that spread outward aren't random, they're a record of where you touched the surface. Now picture our universe as that pool, and the axis of evil as ripples from something far stranger, a collision with another universe in the vast, frothing ocean of the multiverse. This isn't just wild speculation. The mathematics behind inflationary cosmology, the idea that our universe expanded exponentially in its first moments, naturally predicts the existence of other bubble universes, each with their own physical laws. If two of these bubbles bumped into each other during that chaotic early phase, the energy released could have left behind a permanent mark on the cosmic microwave background, like a bruise on spacetime itself. The axis of evil's eerie alignment and the cold spot's inexplicable chill could both be remnants of that ancient impact, cosmic fossils hinting at realities beyond our own. Some models go even further. If another universe grazed ours, its gravity might have subtly warped the distribution of matter in our cosmos, nudging galaxies into strange alignments or creating dark flow's mysterious tug. Think of it like two soap bubbles merging in midair. The spot where they touch isn't smooth anymore. It's distorted, stretched, forever marked by the encounter. That's what the axis of evil could represent, not a flaw in our theories, but evidence of something far grander lurking just beyond the edges of our observable universe. Of course, not all physicists are convinced. Critics argue that multiverse explanations are untestable by nature. If other universes are permanently hidden from us, how can we ever prove they exist? But supporters counter that anomalies like the axis of evil are the test. If no conventional explanation fits, and the data keeps pointing toward a preferred direction in space, maybe we're seeing the shadow of something from outside our cosmic bubble. The implications are staggering. If true, it would mean our universe isn't just one isolated island of reality, but part of an unimaginably vast archipelago, a multiverse where the laws of physics might shift from one bubble to the next. The axis of evil wouldn't just be a puzzle to solve, it'd be our first glimpse into a reality far stranger than we ever dreamed, and that's the beauty of this mystery. Whether it's proof of the multiverse or something else entirely, one thing's certain: the universe is nudging us toward a revolution in understanding, one anomaly at a time. What if the axis of evil isn't just a cosmic anomaly? What if it's the universe's version of a software bug, simulation theory? The idea that our reality might be an artificial construct has long lurked at the fringes of science and philosophy. But when you look at the universe's strange alignments through this lens, things get uncomfortably compelling. Think about it. In any simulation, even the most advanced one, there are bound to be imperfections, tiny artifacts in the code that reveal the underlying structure. The axis of evil could be exactly that, a cosmic slip-up where the programmers forgot to randomize the variables properly. Picture a video game where the developers cut corners. Maybe they reused the same tree model too many times, or the shadows all fall in the same direction no matter where the sun is. Players notice these glitches because they break immersion. Now imagine our universe is that game, and the axis of evil is the shadow that always points north. It's as if whoever or whatever built this simulation got lazy in one spot, leaving a telltale sign of design. Even stranger, the cold spot and dark flow could be similar artifacts, regions where the simulation's physics engine stuttered under the load. Not everyone takes this idea seriously. Critics argue it's untestable. How could you prove we're in a simulation if the creators control all the rules? But supporters counter that anomalies like the axis of evil are exactly the kind of clues you'd expect to find. In a simulated universe, the laws of physics might not be fundamental truths but programmed approximations, and at extreme scales, like the cosmic microwave background, the shortcuts might show through. Some scientists, like Oxford's Nick Bostrom, suggest that if civilizations eventually run ancestor simulations, the odds we're in the real universe are vanishingly small. The most unsettling part, if the universe is a simulation, the axis of evil might not be a mistake at all. It could be a deliberate Easter egg, a breadcrumb left by the programmers to see if we're smart enough to notice. Or worse, a sign that the simulation is starting to degrade, like a hard drive with corrupted sectors. Either way, the implications are staggering. It would mean everything we know, from the Big Bang to the laws of quantum mechanics, is just someone else's code. Of course, not all glitches are proof of a simulation. The universe is perfectly capable of being weird on its own, but the fact that we're even having this conversation shows how deeply these anomalies unsettle us. Whether it's a programming error, a hidden dimension, or something else entirely, the axis of evil forces us to confront a humbling possibility. The universe might not just be stranger than we imagine, but stranger than we can imagine. And that's what makes the hunt for answers so exhilarating, because every anomaly, every cosmic glitch, is a chance to peek behind the curtain of reality itself. For decades, dark matter has been the universe's invisible scaffolding, a mysterious substance we can't see, but whose gravity holds galaxies together. But what if dark matter doesn't exist at all? That's the radical proposition of modified gravity theories, which rewrite the rules of Einstein's relativity to explain cosmic anomalies without invoking unseen particles. The most famous of these is modified Newtonian dynamics, a theory that suggests gravity behaves differently on galactic scales than our textbooks predict. Picture a car speeding down a highway. According to Newton's laws, if you take your foot off the gas, the car should gradually slow down. But imagine if, below a certain speed, the brakes suddenly stopped working, the car would coast farther than expected. That's the core idea behind MND. At extremely low accelerations like those at the outer edges of galaxies, gravity might strengthen just enough to keep stars from flying away, eliminating the need for dark matter's extra pull. When scientists applied MND to galaxy rotation curves, something astonishing happened. It predicted their shapes with eerie accuracy, matching observations better than standard dark matter models in some cases. But here's the catch. MND struggles to explain larger-scale phenomena like galaxy clusters or the cosmic microwave background's intricate patterns. That's where even more exotic modified gravity theories step in. Some propose adding tiny corrections to Einstein's equations, making gravity subtly stronger across vast distances. Others suggest space-time itself has a kind of memory, where past gravitational interactions leave faint imprints that alter future motions. These theories aren't just tweaks, they're wholesale reimaginations of how gravity works, designed to account for everything from the axis of evil's alignments to dark flow's mysterious tug. Yet the debate is far from settled. Critics point out that while modified gravity excels at explaining individual galaxies, it falters when faced with the bullet cluster, two colliding galaxy clusters where gravitational lensing reveals mass separated from visible matter, a smoking gun for dark matter's existence. Supporters counter that perhaps we're missing a piece of the puzzle, like unseen quantum effects or undiscovered particles that interact differently with gravity. What makes this clash so thrilling is that both sides could be partially right. Maybe dark matter and modified gravity aren't mutually exclusive. Perhaps the truth lies in some hybrid model we haven't yet conceived. Or maybe these anomalies are pointing us toward an even deeper truth. That gravity, the force we thought we understood, is far stranger than we ever imagined. One thing's certain: when the universe throws us a curveball this big, it's usually a sign we're on the verge of something revolutionary. And that's where the real excitement begins. What if the universe had scars, not just metaphorical ones, but actual cracks in the fabric of reality? Enter cosmic strings, hypothetical defects in space-time so thin yet so dense, a single mile of one might weigh more than Mount Everest. These bizarre structures, if they exist, could be remnants of the universe's violent birth, formed when the cosmos cooled unevenly after the Big Bang, like fissures in ice as it freezes. And here's where it gets wild. Cosmic strings could be the invisible puppeteers behind the axis of evil's eerie alignments. Picture space-time as a stretched rubber sheet. Normally, it's smooth, but cosmic strings would slice through it like razor-thin wires, creating permanent creases in the universe's structure. Anything passing near these strings, light, galaxies, even the cosmic microwave background, would feel their gravitational tug, warping its path or distorting its appearance. If a cosmic string happened to stretch across the observable universe, it could nudge galaxies into alignment or imprint a preferred direction on the cosmos, like a scratch on a vinyl record that makes the needle skip in the same spot every time. That might explain why the axis of evil's hot and cold spots seem to line up along a mysterious axis. They're tracing the shadow of a space-time defect we can't yet see. The math behind cosmic strings is startlingly elegant. Unlike black holes or dark matter, which require complex particles or extreme conditions, strings emerge naturally from the physics of phase transitions, the same process that creates cracks in freezing water or defects in crystals. In the early universe, as energy fields settled into their current state, tiny imperfections might have stretched into cosmic strings, threading through the cosmos like flaws in a diamond. Some theories suggest these strings could be nearly infinite in length, looping around the universe or even stitching multiple universes together in a vast multiverse. But here's the kicker: cosmic strings wouldn't just sit there. They'd vibrate, snap, and even emit bursts of gravitational waves as they interacted with each other or decayed over time. These vibrations might leave faint echoes in the cosmic microwave background, subtle swirls or discontinuities that telescopes like Planck or future observatories could detect. Already, researchers are scouring sky maps for telltale signs: sudden jumps in temperature, strange lensing effects, or unexplained gaps in the universe's oldest light. If found, cosmic strings wouldn't just solve the axis of evil mystery, they'd rewrite our understanding of spacetime itself. Of course, skeptics argue that cosmic strings are still speculative, with no direct evidence to confirm their existence. But that's the thrill of cosmology. Sometimes the wildest ideas are the ones that turn out to be true. After all, black holes were once dismissed as mathematical curiosities until we found them lurking in the hearts of galaxies. Whether cosmic strings are real or not, their possibility forces us to ask a deeper question. Is the universe we see truly seamless, or is it riddled with hidden fractures? The answer might be written in the sky, waiting for us to decode it. Trying to study the axis of evil is like trying to read a book while looking through a straw, except the book is the size of a continent and you're standing a mile away. The sheer scale of this cosmic anomaly is staggering. We're talking about alignments that stretch across billions of light years, patterns so vast they dwarf entire superclusters of galaxies. And yet, the tools we have to observe them, our telescopes, our satellites, are limited by fundamental constraints. Take the cosmic microwave background, for example. It's the oldest light in the universe, a snapshot of the cosmos when it was just 380,000 years old, but mapping it with perfect accuracy. That's like trying to photograph a snowstorm from space and distinguish every single flake. The problem isn't just distance, it's precision. Instruments like the Planck satellite measure temperature variations in the cosmic microwave background down to millionths of a degree. But even the tiniest calibration errors or instrumental noise can distort the data, creating false signals that look like anomalies. Imagine trying to listen for a whisper in a hurricane. That's the challenge scientists face when hunting for clues in the universe's faintest echoes. And then there's the issue of perspective. We're stuck inside the universe, observing it from a single vantage point, a bit like an ant trying to map a football field by crawling across it. What looks like an alignment from our viewpoint might just be a trick of geometry, a cosmic illusion caused by the way light bends and warps over incomprehensible distances. But perhaps the biggest hurdle is time. The universe doesn't hand us a live feed of its secrets. The light from the cosmic microwave background took 13.8 billion years to reach us, carrying information frozen in the distant past. By the time we detect it, the universe has evolved beyond recognition. It's like trying to solve a murder mystery where the only clue is a shadow left at the scene, a shadow that's been fading for billions of years. The axis of evil might not even exist in the same way today. Galaxies drift, structures evolve, and the universe's expansion stretches space-time itself. What we're seeing could be the ghost of an alignment that's long since unraveled. And yet, despite these obstacles, scientists keep pushing the limits of observation. New telescopes like the upcoming Simons Observatory and the next generation of space-based instruments promise unprecedented clarity. They'll peer deeper into the cosmic microwave background, filter out more noise, and maybe, just maybe, pin down whether the axis of evil is real or a cosmic mirage. Because if there's one thing the universe has taught us, it's that the biggest mysteries often hide in the smallest details, and the only way to find them is to keep looking, even when the odds seem impossible. The axis of evil doesn't just puzzle scientists, it splits them into warring camps. On one side, you have researchers who shrug it off as cosmic static, a statistical blip in the noise of the universe. To them, it's no stranger than flipping a coin and getting heads 10 times in a row, unlikely, but not impossible. They argue that with a universe as vast as ours, even the most improbable patterns will emerge somewhere. After all, stare at random dots long enough and your brain will start seeing faces. Could the axis of evil just be our collective minds playing tricks on us? Then there's the other side, cosmologists who call it an existential threat to modern physics. These aren't fringe theorists, they're respected scientists like Joe Megiddo and others who have staked their reputations on the idea that this anomaly is real, and it's screaming that something's broken in our understanding of the cosmos. To them, dismissing the axis of evil is like ignoring a crack in the foundation of a skyscraper because it's probably just a scratch. The stakes, only the entire framework of cosmology, from the Big Bang to dark energy. The heart of the debate boils down to probability. How likely is it that the cosmic microwave background's hot and cold spots would align so perfectly by pure chance? Detractors point to later analyses suggesting the effect might weaken with more precise data. But supporters counter that each new observation, like the Planck satellite's findings, keeps showing the same eerie signal. It's like a game of cosmic whack-a-mole. Every time someone tries to explain it away, the anomaly pops back up somewhere else. Then there's the middle ground, scientists who admit the axis of evil is weird but argue we're missing a piece of the puzzle. Maybe it's not a flaw in our theories but an overlooked factor, like subtle distortions from interstellar dust or undiscovered quirks in how light travels across the universe. Think of it like a detective story where every suspect has an alibi. The crime happened, but the usual explanations don't fit. That's when you start questioning whether you've misunderstood the rules of the game entirely. What makes this debate so electrifying isn't just the science, it's the philosophy. At its core, the axis of evil forces us to ask, how much weirdness are we willing to accept before we tear up the rulebook? History's full of moments when scientists clung too long to comfortable ideas, only to be blindsided by reality. The universe owes us no favors, it doesn't have to make sense or play fair. And that's why, whether you think the axis of evil is a glitch or a revolution in the making, one thing's certain. It's a reminder that the cosmos still has the power to surprise us. The mystery of the axis of evil might not stay unsolved for long. a new generation of telescopes armed with technology far beyond anything we've had before is gearing up to turn their gaze toward this cosmic riddle. Leading the charge is the European Space Agency's Euclid spacecraft, a mission specifically designed to map the universe's structure in unprecedented detail. Unlike its predecessors, Euclid won't just glance at the cosmic microwave background, it'll dissect it, measuring distortions in spacetime caused by dark matter and dark energy with a precision that could finally reveal whether the universe's preferred direction is real or an illusion. Then there's the James Webb Space Telescope, which has already revolutionized our view of the cosmos. While Webb wasn't built to study the axis of evil directly, its unmatched ability to peer into the early universe could uncover clues hidden in the formation of ancient galaxies. If the anomaly stems from some primordial asymmetry, a twist in the fabric of reality during the Big Bang, Webb's infrared eyes might spot the telltale fingerprints. Imagine finding galaxies aligned along the same axis billions of years ago, evidence that the universe's strange preference isn't just a modern fluke, but baked into its very foundations. But the real game-changer could be the upcoming Simons Observatory in Chile. This ground-based array of telescopes, set to begin full operations in the next few years, will scan the cosmic microwave background with 10 times the sensitivity of Planck. It's like upgrading from a blurry photograph to a microscopic. If the axis of evil is a faint whisper in the data now, Simons might finally let us hear it clearly. And if the anomaly persists, that's when things get serious. It would mean these alignments aren't just noise, they're a fundamental feature of reality we've been missing. Meanwhile, NASA's SPHEREX mission, launching in the next few years, will add another layer to the puzzle. By mapping the sky in near-infrared light, it could reveal whether dark energy, the force accelerating the universe's expansion, behaves differently along the axis of evil's mysterious alignment. If the expansion rate itself changes directionally, it would be the smoking gun that our laws of physics aren't just incomplete, they're geographically biased. The beauty of these missions is that they don't just aim to confirm or debunk the anomaly. They're designed to explore every possible explanation, from cosmic strings to multiverse collisions. Even if the axis of evil vanishes under sharper scrutiny, the hunt will have pushed our instruments and our imaginations to new limits, because that's how science moves forward. Not by fearing the unknown, but by building tools brave enough to confront it. And this time we might finally get answers. The axis of evil doesn't just defy physics, it defies our place in the universe. For centuries, we've clung to the comforting idea that the cosmos is indifferent, that its laws apply equally everywhere with no special corners or privileged directions. It's a humility baked into modern science. We're not the center of anything. But what if that humility is misplaced? What if, instead of living in a random, uniform universe, we're sitting in a corner with its own peculiar rules? The implications are staggering. It would mean the laws we've painstakingly unraveled, gravity, relativity, quantum mechanics, might not be universal truths. They could be local ordinances, quirks of our cosmic neighborhood. Think of it like this. Imagine growing up in a valley surrounded by mountains, convinced the entire world looks exactly like your hometown. Then one day you climb high enough to see beyond the peaks and discover oceans, deserts, landscapes utterly alien to everything you knew. The axis of evil might be our first glimpse over those mountains. If the universe has a preferred direction, a cosmic north, then the symmetry we've always assumed could be an illusion. Gravity might work differently along that axis. Light could bend in unexpected ways. Even time itself might flow at a different pace depending on which way you're facing. Suddenly, the tidy equations in our textbooks start to look like rough drafts, approximations of a far stranger reality. This shakes something deeper than just science. It challenges our entire philosophy of exploration. Since Copernicus dragged us from the center of the universe, we've prided ourselves on embracing our insignificance. But the axis of evil hints at a universe that isn't just indifferent to us, it's capricious. A cosmos with a preferred direction isn't merely vast, it's structured in ways that might make some regions fundamentally unknowable to beings like us. Could life in a different part of the universe perceive entirely different physical laws? Would their science even resemble ours? The unsettling possibility is that we're not just small, we're provincial, limited by the peculiar physics of our cosmic backyard. And yet, there's a thrilling edge to this realization. If the axis of evil is real, it doesn't diminish our quest for knowledge, it expands it. Instead of searching for one unified theory of everything, we might need a catalog of cosmic dialects, each describing physics as it operates in different corners of existence. It turns the universe from a predictable machine into a living, evolving puzzle, full of secrets we've only begun to guess at. The greatest discovery wouldn't be finding the answer, it would be learning how many questions we didn't even know to ask. The axis of evil isn't an isolated quirk, it's part of a growing list of cosmic mysteries that refuse to fit neatly into our textbooks. Take dark matter, the elusive substance making up 85% of the universe's mass. We can't see it, but its gravitational pull holds galaxies together like invisible glue. Yet when astronomers map its distribution, something's off. Dark matter doesn't spread evenly, it clumps in filaments and voids, forming a cosmic web. But here's the strange part. Some of those filaments seem to align with the same axis as the axis of evil, as if an unseen hand arranged both the visible and invisible universe along a shared framework. It's like finding out two unrelated paintings were sketched with the same underlying grid, a coincidence too precise to ignore. Then there's the Hubble tension, perhaps the most heated debate in modern cosmology. On one side, measurements of the early universe, like the cosmic microwave background, suggest an expansion rate of about 67 kilometers per second per megaparsec. On the other, observations of nearby stars and supernova peg it closer to 73. That gap might sound small, but it's a chasm in physics terms, implying our measurements are wrong, our math is flawed, or the universe's expansion isn't uniform. Now imagine if that discrepancy isn't random. What if it's tied to the axis of evil's preferred direction? Some theorists speculate the expansion rate could vary along different axes, faster in one region of space, slower in another. If true, it would mean the Hubble tension isn't just a measurement error, it's a symptom of a lopsided cosmos. Even the Great Attractor, a mysterious gravitational anomaly pulling thousands of galaxies toward the constellations Centaurus and Hydra, might be part of this puzzle. For decades, astronomers struggled to explain what's generating such a colossal tug. Conventional models suggest it's a supercluster of galaxies, but its influence seems too vast for visible matter alone. Now new research hints its pull aligns suspiciously close to the axis of evil's orientation. Could these phenomena, dark matter's uneven web, the Hubble tension's stubborn gap, the Great Attractor's relentless drag, all be threads of the same cosmic anomaly? The most tantalizing possibility is that we're seeing the fingerprints of a deeper structure, something woven into the fabric of space-time itself. Maybe it's a remnant of quantum fluctuations from the universe's first moments, frozen into the cosmic background like a fossil. Or perhaps it's evidence of a multiverse, where neighboring realities exert subtle pressures on our own, warping galaxies and light in ways we're only beginning to detect. Whatever the answer, one thing's clear: the universe isn't just hiding secrets, it's leaving breadcrumbs, and the trail starts with an axis we still don't understand. Einstein's theory of general relativity has been the gold standard of cosmology for over a century, a framework so robust it predicted black holes, bent starlight, and even the expansion of the universe itself. But the axis of evil throws a wrench into this well-oiled machine. If the cosmos truly has a preferred direction, it challenges one of relativity's core tenets, the idea that the laws of physics are the same no matter where or which way you're looking. Think of it like a compass that always points north, no matter where you stand on Earth. Now imagine that compass behaving differently in Paris than it does in Sydney. That's the level of upheaval we're talking about. The cracks in relativity's armor aren't entirely new. On galactic scales, astronomers have long noticed discrepancies, stars orbiting galaxies faster than Einstein's equations predict, a phenomenon blamed on dark matter. But the axis of evil raises a far more radical question. What if the problem isn't just missing matter, but a flaw in how relativity handles gravity across the vast emptiness between galaxies? Some theories, like John Moffat's modified gravity, suggest gravity strengthens over enormous distances, potentially explaining cosmic alignments without invoking dark matter. Others propose relativity might need tweaks when applied to the universe as a whole, like adding a cosmological term to Einstein's equations, much like he once did and later called his greatest blunder to account for a static universe. The stakes couldn't be higher. If relativity stumbles on cosmic scales, it wouldn't just affect our understanding of the axis of evil. It would ripple through everything from black hole physics to the fate of the universe. Take dark energy, for instance. Its discovery relied heavily on relativity's framework to interpret supernova data. But if gravity behaves differently along certain cosmic axes, could dark energy's apparent acceleration be an illusion? Imagine driving a car with a misaligned speedometer. You might think you're accelerating when you're actually just veering off course. Yet rewriting relativity isn't a task scientists take lightly. The theory has survived every test thrown at it, from the precise ticking of atomic clocks on GPS satellites to the recent detection of gravitational waves. Ditching it would be like abandoning the foundation of a skyscraper because one window won't open. That's why many researchers are probing subtler fixes. Perhaps relativity holds, but our assumptions about the universe's initial conditions are flawed. If the Big Bang wasn't perfectly uniform, if space-time had primordial twists or torsions we've overlooked, it might explain the axis of evil without dismantling Einstein's masterpiece. The beauty of this dilemma is that it forces us to confront the limits of our knowledge. For all its brilliance, relativity was born from a universe far simpler than the one we've since discovered. A cosmos without dark matter, dark energy, or mysterious alignments. The axis of evil might not break Einstein's theory, but it could reveal where the next revolution in physics must begin. After all, even the greatest scientific frameworks aren't sacred, they're stepping stones. And sometimes the most unsettling anomalies are the ones that point us toward the next leap forward. The axis of evil isn't just a cosmic curiosity, it's a cultural lightning rod, sparking imaginations and fueling conspiracy theories with its ominous name and unsettling implications. Sci-fi authors have seized on its spine-chilling potential, weaving tales of hidden celestial empires or ancient alien artifacts manipulating the universe's very fabric. In Liu Cixin's The Three-Body Problem, for instance, an advanced civilization tampers with fundamental physics to destabilize Earth science, an idea that feels eerily plausible when confronted with real-world anomalies like the axis. Even blockbuster films like Interstellar flirt with the concept of a universe that doesn't play fair, where hidden dimensions or unseen forces rewrite reality. The axis of evil taps into a primal fear that the cosmos isn't just indifferent to us but actively designed, and not necessarily in our favor. But where science fiction sees narrative gold, conspiracy theorists see confirmation. Online forums buzz with claims that the axis is proof of a simulated universe glitch or worse, a celestial weapon left behind by some forgotten cosmic architects. The name itself, coined half-jokingly by cosmologist Joe Megiddo, became a gift to doomsayers, evoking biblical prophecies or Lovecraftian horrors lurking beyond the stars. It's not hard to see why. When mainstream science admits the universe might have a preferred direction, it's a short leap for fringe groups to whisper about cosmic rulers or hidden blueprints. The irony, the very randomness the axis challenges is what usually fuels conspiracy logic. Now the anomaly flips the script. What if the universe isn't chaotic? What if it's ordered, just not in a way that comforts us? Even beyond the fringes, the axis has seeped into public fascination with cosmic mysteries. Podcasts and documentaries lump it alongside Bermuda Triangles and Martian faces, framing it as a space oddity science can't crack. But there's a crucial difference. Unlike urban legends, the axis is peer-reviewed, data-backed and real, which makes its mystique even more potent. It's not just a campfire story, it's a paradox, a crack in the foundation of our understanding that even physicists can't gloss over. That tension between hard science and existential wonder is why the axis resonates. It's a reminder that the universe isn't just stranger than we imagine, but stranger than we fear. Yet perhaps the most telling impact of the axis is how it's reshaped scientific storytelling itself. Astronomers once framed the cosmos as a clockwork machine, predictable and impersonal. Now they're forced to entertain narratives peppered with what-ifs and maybes, sounding more like detectives than engineers. The axis didn't just break physics, it broke the aesthetic of physics, trading sterile equations for a universe that feels, against all odds, narratively alive. Whether it's a statistical fluke or a revolution in waiting, one thing's certain: the axis of evil has already left its mark, not just on our maps of the cosmos, but on our collective imagination. And that, in itself, is a kind of power. The quest to understand the axis of evil isn't just happening in distant corners of the cosmos, it's unfolding in laboratories right here on Earth. Scientists are recreating the universe's most extreme conditions, not with telescopes, but with supercomputers, plasma chambers, and even tabletop experiments designed to mimic the bizarre physics that might spawn such cosmic anomalies. Imagine trying to reconstruct a hurricane's formation by studying swirling water in a bathtub. It's a simplification, but sometimes the smallest echoes can reveal the loudest truths. One groundbreaking approach involves simulating the early universe's plasma soup, the searing, particle-filled chaos that existed moments after the Big Bang. At facilities like the Large Hadron Collider and smaller plasma labs, researchers smash particles together at near-light speeds, creating fleeting microcosms of that primordial fireball. The goal: to see if tiny asymmetries in these collisions could scale up to universe-spanning alignments like the axis of evil. Think of it as shaking a snow globe and watching how the flakes settle. If they consistently drift in one direction, you've got a clue. Some experiments have already detected unexpected vortices in quark-gluon plasma, swirls that eerily resemble the kind of large-scale rotational patterns seen in galaxy surveys. It's a tantalizing hint that the seeds of cosmic asymmetry might be baked into physics at its most fundamental level. Then there are the cosmology in a dish experiments using supercooled quantum fluids. In a lab at the University of Chicago, scientists chilled helium to near absolute zero, where it behaves as a frictionless superfluid. When stirred, this fluid forms microscopic whirlpools that mimic cosmic structures, and under certain conditions, those whirlpools spontaneously align along a preferred axis. It's as if the universe's love for symmetry has a loophole, and these lab-grown vortices are the proof. The kicker: these alignments emerge without any external nudging, suggesting the axis of evil might not need exotic explanations, just undiscovered quirks in how order arises from chaos. But perhaps the most audacious attempts involve analog universes built inside supercomputers. Projects like the Millennium Simulation have spent decades crafting virtual cosmoses, each governed by slightly tweaked physics, to see which rules produce an axis-like anomaly. One team at the University of Cambridge ran thousands of variations, altering gravity's strength, dark energy's behavior, even the shape of space-time itself. The surprising result: in simulations where the early universe had a slight tilt, a tiny gradient in density or temperature, large-scale alignments emerged naturally, mirroring the real-world data. It's like discovering that a slightly warped record player always makes the needle skip in the same spot. Skeptics argue these lab replicas are too simplistic to capture the universe's full complexity. After all, no plasma chamber can truly recreate a billion light-year-wide anomaly. But supporters counter that these experiments aren't meant to be perfect copies, they're stress tests for our theories. If even a toy universe with tweaked rules produces an axis of evil, maybe the real one isn't so strange after all. And that's the beauty of this approach. It turns philosophy into physics, trading cosmic wonder for something we can measure, tweak, and just maybe understand. Because sometimes the key to unlocking the universe's biggest mysteries lies not in staring at the stars, but in daring to recreate them right here at home. Statistically speaking, the axis of evil shouldn't exist. It's like rolling a die a million times and getting the same number every single time. The standard model of cosmology, built on mountains of data and equations, predicts a universe that's fundamentally random at large scales. The cosmic microwave background's hot and cold spots should resemble static on an old television screen, chaotic, unpredictable, with no discernible pattern. Yet when researchers calculated the odds of these temperature fluctuations aligning along a single axis purely by chance, the numbers were jaw-dropping. We're talking probabilities so slim they make winning the lottery look like a safe bet. Less than 1 in 10,000 by some estimates. That's not just unlikely, it's cosmically suspicious. Digging deeper, the numbers get even stranger. The alignment isn't just a vague trend, it's precise. Imagine drawing a line through the sky from the constellations Leo to Hydra. The hot and cold spots don't just cluster near this line. They follow it with eerie consistency, like iron filings pulled toward a magnet. Standard cosmological models allow for minor deviations, random wrinkles in the fabric of the universe. But this is a crease running through the entire cosmos, a flaw in the cosmic tapestry so pronounced it's impossible to ignore. When physicists ran simulations of a purely random universe, millions of them, not a single one produced an alignment this stark. It's the statistical equivalent of finding a perfect snowflake in a blizzard every time. Then there's the multipole problem. In cosmology, multipoles are mathematical terms used to describe how energy or temperature varies across the sky. The dipole measures the largest variations, the quadrupole the next largest, and so on. In a perfectly random universe, these multipoles should be independent of one another, like different instruments in an orchestra playing unrelated notes. But the axis of evil reveals something bizarre. The dipole and quadrupole, the two largest patterns in the cosmic microwave background, are aligned, not just loosely, but with a statistical correlation that defies expectation. It's as if every violin in the orchestra suddenly started mirroring the conductor's baton, note for note without explanation. Critics argue that human brains are pattern-seeking machines, prone to seeing order where none exists. They point to the look elsewhere effect, the idea that if you search a large enough dataset, you'll eventually find something that looks significant purely by chance. But here's the catch: the axis of evil isn't a subtle blip buried in noise. It's a siren blaring from multiple independent datasets across decades of observations. Planck, WMAP, even ground-based telescopes all see the same anomaly. That consistency across instruments and methods makes the fluke explanation harder to swallow. It's one thing to spot a face in the clouds. It's another when every camera from every angle keeps photographing the same face. The real twist: the axis of evil isn't just statistically weird, it's physically weird. In a universe governed by relativity and quantum mechanics, there's no known mechanism that could create such a precise, large-scale alignment without violating fundamental symmetries. It's as if someone took a paintbrush the size of the observable universe and dragged it across the sky, leaving behind a stroke we still can't explain. Whether it's a flaw in our models, a glimpse of deeper physics, or a cosmic prank we've yet to decode, one thing's clear: the numbers don't lie. And right now, they're telling us our universe might be playing by rules we haven't discovered yet. The scientific community is anything but unanimous about the axis of evil. Some dismiss it as a cosmic coincidence, while others call it the single most important mystery in modern cosmology. Take Dr. Kate Land, a physicist at Oxford who's spent years analyzing the cosmic microwave background. Her verdict: this isn't just a curiosity, it's a crisis. The cosmological principle is the foundation of everything we do. If the universe has a preferred direction, half our textbooks might as well be fiction. She compares it to realizing the Earth isn't just round, it's a perfect cube. The shock wouldn't just upend maps, it would shatter centuries of assumptions about how planets form, how gravity works, even how time flows. Then there's Dr. Nathan Weiss, a Princeton cosmologist who's far more skeptical. Look, the universe is big, really big. If you stare at any dataset long enough, you'll find patterns that look meaningful. The human brain is hardwired to see faces in clouds and animals in stars. He argues that advanced statistical methods, like those used in his team's recent paper, show the alignment weakens when accounting for subtle measurement biases. Is it weird? Sure, but weird doesn't automatically mean revolutionary. But Dr. Joanna Dunkley, who worked on the Planck satellite team, counters that dismissing the anomaly outright is just as dangerous as overhyping it. When two independent missions, WMAP and Planck, see the same signal, you can't just wave it away. Maybe it's not new physics, but it's definitely new something. She points to the cold spots alignment with the axis as evidence that multiple anomalies might share a common origin. Imagine finding footprints in the snow. One set could be a prank, but when you see them leading to a broken window, you start asking different questions. The most provocative take comes from Dr. Amir Hajian, a researcher who's modeled how quantum fluctuations in the early universe could create large-scale asymmetries. What if the axis isn't a flaw? What if it's a feature? He suggests the alignment might be a relic of pre-Big Bang physics, a fingerprint from whatever existed before space-time as we know it began. We're used to thinking of the Big Bang as ground zero. But what if it was more like a reboot? The axis could be leftover code from the last operating system. Even skeptics admit the debate has value. Dr. Weiss concedes science thrives on anomalies. If the axis makes us double-check our assumptions, that's never a bad thing. And that's the heart of it. Whether the axis of evil is a statistical ghost or a cosmic revolution, it's forcing physicists to ask questions they'd never considered before. Because sometimes the most important discoveries don't start with answers. They start with something in the data that just doesn't make sense. And right now, the universe is whispering, or maybe shouting, that we're missing something big. The axis of evil might sound like something straight out of a horror movie, but let's clear the air. This isn't a cosmic haunting or some celestial curse. It's easy for wild theories to take root when faced with something as mysterious as a universe that seems to break its own rules. You've probably heard claims that the alignment is proof of a designed universe, or even whispers about extraterrestrial architects tampering with reality. But here's the reality: studying the axis isn't about chasing ghosts, it's about chasing data. Rigorous, painstaking, peer-reviewed data. Take the cosmic microwave background, for example. Mapping its temperature variations isn't some abstract exercise, it's a technological marathon. Satellites like Planck and WMAP didn't just snap a photo of the early universe. They spent years collecting measurements so precise they could detect temperature differences of a few millionths of a degree. Every blip, every anomaly was scrutinized for instrument errors, calibration quirks, even the faint glow of dust in our own galaxy. When multiple independent missions keep seeing the same pattern, it's not a glitch or a hallucination, it's a signal. A stubborn, inconvenient signal that refuses to vanish under scrutiny. Then there's the myth that the axis of evil undermines the Big Bang theory. If anything, it's the opposite. The anomaly exists because we understand the Big Bang so well. The cosmic microwave background is a relic of that explosive birth, and its imperfections are supposed to be random, like confetti scattered by a chaotic explosion. The shock isn't that the universe has structure, it's that the structure seems to follow a hidden rulebook. That's not a flaw in cosmology, it's a clue, a signpost pointing toward deeper physics we haven't yet unraveled. And no, this isn't proof we're living in a simulation, despite what viral headlines claim. Simulation theory is a fun thought experiment, but science demands testable hypotheses. The axis of evil is being probed with real instruments, real math, and real debate, not philosophical speculation. If anything, the anomaly highlights how science works. When observations clash with theory, scientists don't shrug and call it magic. They double-check, they argue, they build better telescopes. The axis isn't a dead end, it's an invitation to dig deeper. Here's the bottom line: the universe doesn't owe us tidy answers. Sometimes the most profound discoveries start with something that just doesn't fit. The axis of evil isn't a crack in reality, it's a crack in our understanding of reality. And that's exactly how science moves forward, not by fearing the unknown, but by daring to question it. So the next time someone calls this anomaly haunted, remember, the only specters here are the ones we haven't yet explained, and that's where things get truly exciting. Exploring the axis of evil isn't just a scientific challenge, it's an ethical dilemma wrapped in cosmic mystery. What if unraveling this anomaly doesn't merely rewrite our textbooks, but accidentally triggers consequences we can't foresee? History is littered with moments where humanity's curiosity outpaced its caution. Take nuclear physics. Unlocking the atom brought clean energy, but also Hiroshima. Or gene editing. CRISPR can cure diseases, yet could permanently alter human evolution. The same ethical calculus applies when probing the universe's deepest flaws. If the axis isn't a fluke but a structural feature of reality, a cosmic pressure point, could poking at it destabilize something fundamental? Consider the possibility that these alignments aren't passive scars but active mechanisms. Wormhole theorists suggest the axis might be a topological defect in spacetime, a remnant from when the universe underwent phase transitions in its infancy. If so, could studying it with increasingly powerful instruments, like blasting it with focused gravitational wave detectors or quantum sensors, unwittingly vibrate this cosmic fault line? The worst-case scenario sounds like sci-fi, accidentally collapsing a false vacuum where a ripple in quantum fields propagates at light speed, rewriting the laws of physics across the cosmos. The odds are infinitesimal, but as philosopher Nick Bostrom notes, even microscopic risks of existential catastrophe demand serious consideration when the stakes are everything. Then there's the knowledge paradox. Some truths might be inherently dangerous to comprehend. In astrophysicist David Brin's novel Existence, civilizations self-censor certain discoveries to avoid attracting predatory aliens or triggering apocalypses. While that's fiction, the principle holds. If the axis reveals a universe finely tuned or worse, engineered, does that knowledge itself become hazardous? Imagine learning the cosmos has a preferred direction because it's leaning against something far larger. The psychological impact alone could dwarf Copernicus' demotion of Earth from the center of creation. Entire belief systems, from religions to scientific paradigms, might fracture under such revelations. Yet hesitation carries its own risks. What if the axis holds clues to surviving cosmic threats we don't yet perceive? Its alignment with dark flows suggests our universe is being tugged by something outside our observable horizon. Is that attractor a neighboring universe? Or an approaching danger? The Great Filter hypothesis warns that advanced civilizations might inevitably stumble upon self-destructive truths. but refusing to investigate could leave us blind to existential risks like vacuum decay or a looming Big Rip. As astronomer Martin Rees argues, the cost of not exploring might be greater than the perils we fear. The debate echoes through labs worldwide. Proponents of interventionist cosmology advocate active experiments like manipulating quantum fields to test the axis's resilience. Detractors call this cosmic recklessness, urging passive observation only. Striking a balance will define our era. Perhaps we need new ethical frameworks, cosmic equivalents of the Large Hadron Collider's safety reviews, where multidisciplinary teams assess not just what we can learn, but what we should. Because the universe's greatest anomaly might not be the axis itself, but our own audacity to probe it without understanding the rules of the game we're playing. The axis of evil doesn't just challenge our understanding of the cosmos, it redefines what it means to explore at all. Think about it. We're used to a universe that follows rules, a predictable stage where gravity pulls and light travels in straight lines. But this anomaly, it's a crack in that stage, a reminder that behind the curtain, reality might be stranger than any script we've written. Whether it's a statistical fluke, a glimpse of the multiverse, or a sign that gravity itself needs rewriting, one thing's certain: the universe is nudging us toward a humbling truth. We're not just uncovering its secrets, we're realizing how many we've missed, and that's the real thrill here. Every great leap in science began with something that didn't fit: a wobble in Mercury's orbit that hinted at relativity, a faint static hiss that revealed the Big Bang. The axis of evil could be the next domino in that chain, a puzzle piece that forces us to rethink everything from the birth of the cosmos to the nature of space-time itself. Maybe it's evidence of a universe tilted on its axis, or a shadow from beyond our cosmic horizon. Or maybe it's proof that the questions we've been asking aren't even the right ones yet. So here's where you come in. The most exciting part of science isn't the answers, it's the conversation. What do you think is causing the axis of evil? A cosmic string, a parallel universe, something no one's even dreamed up yet. Drop your wildest theories in the comments, because history shows us the next big idea could come from anywhere. After all, the universe isn't just a mystery to solve, it's a story we're all writing together. And if there's one thing the axis of evil teaches us, it's that the next chapter might be stranger than anything we've seen so far.